time. So welcome everyone. This is a presentation by the Fallbrook Climate Action Team. And if you are new to the group, we are a nonpartisan group of volunteers concerned about climate change. And we bring you various topics on the last Tuesday of each month. And next month, we are going to have Bob Hill from EBCO speaking on recycling. So what can go into our bins, and then what do they do with it once it leaves your curb? So that will be next month. I think that is the, what is the date of that? The 29th, so June 29th. And then we have just one real quick announcement. We've been mentioning this over the past several months, but we are still doing our Cut the Carbon tree planting program, which is in partnership with Save Our Forest. And that's where you can get a tree at a discount and have Jackie Heineman come and help you decide the best type of tree, where to put it, which is the best place to help make your home energy efficient, still letting sun through when you want it. And then you also get a free 1-year membership included with that to the Fallbrook Land Conservancy. So a really good deal. If you're interested in that, go ahead and send a email to Tim. Tim, why don't you put your email up in the chat box? And then he will put you in contact with Jackie and we'll make it happen from there. So just a few ground rules before we get started. To keep background noise down, we're going to mute everyone. And then if you have a question, the best thing to do is use the chat function. So just scroll down to the bottom of your screen. You'll see a box pop up that says chat. Click chat, and then another box pops up over to the side, and then you can type your message in there. And that way we can not interrupt Dan while he's speaking to us, but yet you don't have to remember your question all the way to the end. And then at the end, we'll go ahead and go through and read those questions, and we'll do a Q&A with Dan. So tonight we have a topic about how communities can turn organic waste into products. And we have Dan Noble on the line with us, and he's the CEO and co-founder of Environmental Business Journal and Noble Bioresources, Inc. Hopefully I got that right, Dan?
Yep.
And he has over 30 years experience with environmental market research and strategic consulting. So with that, Dan, I'll go ahead and turn it over to you. I don't know if you want to add anything to the introduction there, but we'll go ahead and turn it on over.
Yeah, I'll kind of be introducing myself through the presentation. So the other thing that I do part-time, but continuously for the last 20 years, is that I'm the executive director of the Association of Compost Producers, which is the California state chapter of the U.S. Composting Council. And so I don't work necessarily directly with farmers, but in some of the work that I do, and I know you're not all farmers, but you're all interested citizens in Fallbrook, about climate change and what we can all do to both mitigate it as well as participate in our communities. So my focus is expanding the bioproduct markets in the local community. And therefore, and because of my marketing background and quantitative marketing background, in addition to, I have a science background. I graduated from UCSD. I met my wife in La Mesa during that time. And that was 50 years ago. So we've been married, but we moved up here to be with our son, who was raised in San Diego in La Mesa, and who went to Grossmont College where we met. And then he moved up here, and then we followed him after. and so now we're in parallel businesses. He's in the water business, and I'm in the organics business. But I'm very involved at the community level, because I think, as you'll see in my presentation, it's all about local community and local economics. And it relates to, I do carbon monitoring projects, carbon emissions projects with other clients. But I'm not going to spend a lot of time talking about that. But at the same time, what I am talking about today is what are called uncommon activities. For example, we're working with a client right now who is an investor in a bunch of compost and wastewater facilities, both municipal and private, as well as a lot of greenhouses all over the United States. And these investors are looking to make their investments greener. And as many of you may be aware of environmental, social, and governance investments, the ESG, which is, part of the NASDAQ as well. So not all businesses are alike. A lot of our, obviously, and a lot of the businesses in our section of the industry are not just private businesses. Some of them are nonprofit social enterprises. Some of them are municipal businesses, like right there in San Diego City. The city of San Diego owns and operates Miramar Greenery, which is a separate compost facility. You have composters all around you, and San Pasqual Valley Soils over in Escondido in the San Pasqual Valley. Agri-Service down in Oceanside. So many of you may be customers. But I'm taking one step back and talking about the whole bioresources economy, or what one of my associates out of Minnesota has a company that he calls Renewable Carbon Management. And he's been composting so long that his URL is composter.com. So, and he was one of the founders of the National Association. So we're a community of practice that's growing, and in California, it's definitely growing thanks to all of the environmental laws that we've put into place. And we're using those laws to grow this industry rather than restrict. And it is restrictive of the other industries. So what I want to give you today is a bioeconomic framework and how it relates to all of the activities from our home up to the macro economy. But I'm going to spend most of the time in what I tend to be referring to now as the mesoeconomy, which is really community economics. It's the community, whether it's Fallbrook, whether it's Oceanside. We did a large project with Oceanside about what are they doing with their biosolids, which right now are going to Yuma, Arizona. And we did projects for Orange County, where they were building compost facilities that they are owning and operating at their landfills. So while I will have a focus on compost, it's not exclusive. And I'll discuss some of the models we're using, which are different than the models of what we refer to as the linear or extractive economy. I'll be going through these, and then we can have some discussions about models, resources, technology, and community as it applies to Fallbrook and San Diego County, or even North County. And I'm familiar with all of those, very intimately familiar. I bought my first house in Hamul when I was 18. I used half of my college money because I went to Grossmont instead of UCSD. And then that, when my wife to be moved, and we moved out to go live closer to UCSD, that house burned down in the Laguna fire in 1970, a week before we were married. So, and then we came up here and moved into Coffee Park. We were only renting, that one we owned, but we were renting up here. And in 2017, that one burned down because Coffee Park, the whole neighborhood wiped out about 1,000 homes in that neighborhood, and we were renting one of them. So we evacuated, and now we were part of the PG&E lawsuit. So we've had a lot of direct experience with bioresources that don't behave properly, thanks to global warming. So my company, which I just founded 2 years ago, Noble Bioresources, was founded on how do we basically promote bioproducts, which creates the circular economy, which I'll talk a little bit more about. Three parts of our activities are consulting. We have an active consulting network. My network is over 100 consultants throughout the state that do this kind of work. We're building a database for investors and marketers so that they understand how to do business in the circular economy, whether they're for-profit, nonprofit, or municipalities, or even college campuses, which are in this business, because we're all in this business, either as a customer or a producer or both. And then we have another piece where we're actually selling these equipment units and trying to right-size them for the feedstocks in every local community that needs them. And every community in California has bioresources that they need to manage. So this is an emerging market. But what do we mean by bioresources? Primary, it's basically the food and fiber system. Food, fiber, I call it the 6 Fs: food, fiber, feed, fuel, flowers, and fertilizer. But I left off the flowers and fertilizer part here. But most of the ag, as you guys already know, in San Diego is horticulture. But of course, avocados are big. You were talking about that earlier, and certainly oranges, citrus. And San Diego County is still one of the largest ag county in terms of productivity, thanks to that. But so we do a lot of research in ag as far as those markets. In fact, I was on the phone with growers and crop advisors just this afternoon because we're trying to figure out how compost fits into their normal cropping practices and how can we make that more efficient. But the secondary bioresources, what's called in statute organic waste, is what we deal with, which is landscape clippings, food scraps, manure, and biosolids, which is made from sewage sludge. But it's not directly sewage sludge. It's gone through anaerobic digestion and active aeration and so forth. We can talk more about any of these feedstocks if you want. And of course, the feedstocks are made into a whole suite of bioproducts. And we refer to, whether it's mulch, compost, and biochar. Biofertilizer is another name, and how that's different from organic fertilizer we could talk about. Electricity, biofuels, chemicals, and material products. So just, some pictures. Most of the soil amendments all look, brown or black. And they're all, and I work with all of these producers to determine what is the right mix. In fact, our state association, the URL is healthysoil.org. So we're all concerned about the soil environment and why is carbon important and how does carbon jumpstart carbon drawdown through our plants and so forth. And all of that's now being monitored quantitatively, but we're still in the very early days. And so one of the reasons investors don't invest in this is, first of all, it's not a high profit market like, for example, information systems or cell phones and things like that, but it's an essential market. In fact, it's considered essential infrastructure. And then, of course, it can be used to produce electricity, biofuels, and then the chemicals and products. But what is bioprocessing? Well, you kind of heard me talk a little bit about it: mulch production, composting, biofertilizers, biochar, and so forth. And these are just some examples. Here's a turned windrow, which is mechanically turned by this Scarab windrow turner. Here's a biochar production facility, and this is an anaerobic gas, which is basically methane. And we refer to it, because of the renewable feedstocks, as renewable natural gas. And when you're doing carbon accounting, by the way, renewable, these feedstocks are considered carbon neutral, so they do not contribute to the net overall greenhouse gas. And in fact, if you use compost properly or appropriately, you actually can be carbon negative, because the compost causes the plants to pull more carbon out of the atmosphere and put it in the root structures, which then, when those die, the carbon stays there for long periods of time. So we can use compost to help jumpstart carbon sequestration in ag lands. And that whole practice is gaining steam, and it's variously referred to as carbon farming or regenerative farming. So how is the economic system different? The linear one is basically a take, make, use, dispose, and pollute economy. And so the externalities of the pollution are not accounted for in the economic. You know, we internalize the value of these processes, but we externalize the costs and the pollution to both people and the environment. The goal is to internalize both the values and the liabilities in the circular economy. And that's normally thought of as just recycling. But in the bioeconomy, we're not just recycling the materials, we're also recycling the water. And another way to display this is in what some folks are, you know, the more elaborate circular economy. And it's really a regenerative economy by design and restorative. And we divide the economy into basically bioresources, which is biological nutrients, and georesources, which are sometimes referred to as technical nutrients. Now, certainly oil is a geonutrient or a georesource. Originally it was biological, but it was formed through geological processes over millions of years. And so all that sequestered carbon that we've released in the atmosphere over the last, especially since the Industrial Revolution for the last 150 years or so, or more, is what's causing the global warming problem. So the question is how can we transform this economy to become essentially internalized? And we certainly can't do without plants and food, and we can't do without rocks and building materials, you know, turning into metals and all of that stuff. So this new economy behaves a lot differently than the old economy, and whether you're winning or losing economically, as well as environmentally, as well as socially, all has to be taken into account. And there's a lot of investors, particularly the large investors in the pension funds and in the green funds and so forth, that are trying to figure this out. That's why we need these new models, because we can't get there using the old models, the old ways of not only of thinking, but of calculating and determining what is wealth and what is profit. So my company, we've focused down to just the bare part of the bioresources economy, where all of, you know, kind of begins here with the food and landscape system, which then, you know, becomes the bioresource feedstocks, which then get transported either to an off-site facility or an on-site facility. And then once the products are manufactured, they into the suite of bioproducts that I was talking about, it goes out and is marketed and used by buyers, which then generate their own waste through that system again. And they don't, you know, the farther away the farms and the forests are from the city, which of course they are, except for the landscapes and the amount of landscapes you have in cities, that's where the transportation comes in. And of course, the more you have to transport, the more fuels you're going to have to use. Now we are turning, you know, we do have an objective to be essentially no carbon fuels by 2050 or so. But we can probably get there faster if we have as an intermediate the biofuels. So that's a big policy and as well as market discussion that's happening in California and in communities throughout California. When we look at this is something where I spend a lot of time with my clients, because the value volume curve is where you have the high volume products, but they're low in value. And a lot of compost is in this range right here. This curve is only showing pretty much bioenergies and biochemicals. But then you have the higher value, lower volume products. And so you have a whole suite of products along this curve, and whether they're economic or not, it depends on your own particular business and business model and the markets for those local products. For example, while biochar, and they talk about bioheat here, combined heat and power or biofuels are all in this low range. But that means that we have a whole suite of, a whole economy that we can build, and we are building, and we have built. Now the question is, how do we grow it? And so the ACP is the Association of Compost Producers. So our marketing strategy is to raise the value and volume, and this is our mission, to raise the value and volume of compost being produced and used in California. So our goal is to go from the trashy, bad compost, which should never be used. Ideally, you can produce a high quality compost based on feedstocks, based on your production, based on your knowledge, and based on the crops that or landscapes, and even natural and working lands where you're using it. So that's kind of the big picture from a strategic perspective. But I've been talking about enterprises, and I keep making and want to make the point that all of us inhabit, 4 or more categories of enterprises at different points in our life or throughout our life. Public is, of course, we're all part of a government that manages these resources, both in terms of the water system and the waste system. That was another thing I forgot to mention. I was in the water industry during the 90s, and my son is still in the water industry. He works for a company called HydroPoint Data Systems, and they have weather-based controllers. So water conservation is really important. But of course, bioresources require water. You can't run this cycle without water. There is no life without water. So I often consider water as the ultimate bioresource. Our bodies are, 60% more or less water by weight. So we're carrying around a lot of water, and it's absolutely essential for all of our cells. Even all the plants have more or less water, depending on, the fruiting bodies obviously have more, but even, the cacti and the water, the water poor areas, plants have evolved to store lots of water. So there is no water without that. And also water is used extensively in the geosphere. That's where we get our groundwater from, and then the watersheds. So the watershed and the product sheds are highly commingled, and water quality is really important. Air quality is really important to the regenerative economy. So we work with regulators to improve the environment while we're improving the economy. So environmental justice and all of those factors factor into these strategies. But in addition to that, what makes the circular economy more challenging is that it is a mixture of public and private companies as well as nonprofits. It's really been the social and environmental nonprofits that have driven the movement of the economy, and they've used government leverage through regulations to do that. Of course, the regulations apply to all entities, not just private companies. So the waste companies and the water companies, which are most of the water companies are public, practically all of the wastewater companies are public, except for those wastewater treatment entities that are associated with food production, which are not trivial. I mean, those are major operations for our food system. And then nonprofits are important, whether it's your church or whether it's your Grange or your Farm Bureau, or like our Compost Association is a nonprofit. And then, of course, none of this would be happening if we hadn't had massive education and research to bring us to this place. And so I work with, the universities constantly to improve our knowledge and our behavior, as well as to educate the next generation into these new, into this emerging economic system. So it is a community process. And regenerative economic development requires all of the stakeholders, not just any one group. And right now, most of the working and the reading and studying and researching that I'm doing is what are the social processes that bring all these groups together on an ongoing basis. And that's not trivial, because we've gotten siloed in order to increase efficiency. But to have all of the relationships between all of these groups, the NGOs, our own homes, our businesses with small or large, industrial production, small or large, at all scales, farms, of course, and then the government, down to the community groups through, your municipalities. Like, to me, Fallbrook is a very right-sized community, but no one person can be involved in all of these. So how do you create structural networks that allow for this transformation to transform our economy to become not only greener, but less, to basically reduce carbon in the atmosphere, while at the same time we build jobs that people can live off of, and so this is where I spend a lot of my time, not just often in the business somewhere. And food, water, and energy are absolutely essential, and without shelter, and of course, food, water, and energy flows through all of our shelters, and we're moving from the non-renewable sources to the renewable. And of course, my focus is on bioenergy, even though solar and wind will probably continue to play a bigger role. Bioenergy plays a big role. There's a separate association in California called the Bioenergy Association of California, and they're already 5 times bigger budget than the Compost Association. So there's a lot of money focused on the energy piece. And whether we put the carbon in our gas tanks or whether we put the carbon in our soil is a big deal. And the water cycles and the carbon nutrient cycles, not carbon nitrogen, whether it's carbon and NPK in the soil, or whether it's carbohydrates and protein in our diet, we're all part of these cycles, every day. Just breathing, we're part of these cycles. So the point is how is this economy, part of the environment rather than separate from the environment? Now, this slide is probably getting too techy, but I came up with this when I was working with Sonoma State University, and we were trying to figure out what they should do on-site versus off-site. And so what we realized is that the generation of the waste versus the processing of the waste, and then the use of a product or the sale of a product has 8 different permutations, whether it's on-site or off-site. If it's all on-site, it's on the generator site. Like the college campus produces about 100 tons of wood a month. And currently what they're doing is they produce it on-site, they send it off-site to be processed, and then it comes back on-site, And so there's transportation and costs involved in that. So what we try to do is optimize what is the right plan for you on your property or on your structures or on your facility or on your institution, because we have all those scales, everybody, from a single home to, a college campus, a big college campus, or a big, industrial complex. So this factors into what is the right sizing, because you can't maximize any one of these variables. That's mathematically and logically impossible. The best you can do is optimize them. So I've kind of coined a term that I call collaborative optimization. And that's part of this social process. How do you optimize all of the, the values of each of these communities without ripping off or marginalizing any one of the others? That's the social challenge that we're faced in the midst of this economic and technical challenge, as I see it. And then the complexity of the bioeconomy is that we have all these types of incorporation, all these types of entities. We have a lot of different types of enterprises. We have a lot of communities, starting with the biome itself, and then the population density, urban versus rural, and then water and energy in terms of stocks and flows from either locally or far away, and then the ag-urban to urban ratio in the community. Like how far does your food have to come? So these are kind of the markets that we really speak to. The first 3 are pretty much the soil markets, and then bioenergy is kind of off by itself. Ag, of course, is a big energy market, considering the energy involved in tillage, and but most of the energy, of course, comes from the sun to grow the things. The watershed management and the low impact development is kind of an offshoot of the landscape market. And now there's a lot of attention to the natural and working lands. So where we preserve, 30% of our natural and working lands and conserve them by 2030. But conserving doesn't mean not using. It means managing them sustainably and in fact, better than sustainable to be regenerative. So the decision models involve the feedstock portfolio that you have for your bioprocessing unit, your technology, all the technologies that you have available to you, worm castings, for example, compost, anaerobic digestion, combined CHP, combined heat and power, pyrolytic conversion to do biochar, as well as syngas, and even biorefineries that do produce that fuel. And so the market portfolio is complex, and that's the reason that we are developing the data for all of these things, all of these constituents in the bioeconomy. Because you got to treat it as a whole, even though it's highly fragmented and hugely diverse. And we want it to be more diverse, not less diverse. So, so I'm kind of done, but at the same time, I wanted to just say that I'm continuing to study these mental models, I guess you could call them. They're regenerative industry and economic models. One has been referred to by Anielski, Mark Anielski, as genuine wealth and the 5 forms of capital. Another is that I've been working with is that understanding that these values, these forms of capital are not, separate like he has on his diagrams, but they're more embedded. And I'll just walk through these very briefly. And then some other economists, particularly out of England, most of these are out of England, and I already talked about this, what is also referred to as the butterfly economy, the 2 wings, the bioresource wing and the georesource wing. And then there's something that Kate Raworth out of Oxford talked about, the Doughnut economy. And I just want to show you some of those models, because those are the things that are very extant. In fact, Doughnut economic models are being applied by Kate and her consulting team in the city of Amsterdam as we speak. So these are not just pie in the sky things. These are all being tested in ground truth. Oh, this is kind of fuzzy. Okay, well, the 4 types of, in fact, I'll go to here because you can read it better. Financial capital, or economic or financial capital, human capital, which is, our own intelligence and behavior individually. Socially, it's how our social networks create capital. And of course we do as a population. And that's our society and our economic systems that are part of the financial capital. Natural capital, of course, is what we're all contained in. And then there's built capital, which is all of our artifacts and our homes and our, roads and bridges and all of the rest of it. All of these forms of capital need to be optimized in order to create what Anielski refers to as genuine wealth. And you can put it on a circular diagram like this and measure that. But I think one of the problems with this model is that we think of these wealths as being somehow separate. And therefore you get into this mindset that they're competing against each other and you need to maximize one over the other. Of course, the current capital system, the goal of corporations have fallen into the trap of maximizing, shareholder value at the expense of the local communities and of labor and of the environment. And that's not going to get us to where we need to go. But how can we use the engine of capitalism to move forward? I think one way to think of it differently, and this is that, the whole financial world is an artifact of human thinking and human monetary systems. And humans, each of us as humans, are really a member of a population of humans. Our culture, our tribe, our family, and our tribe, and then our cities and states and nations, and then in the world. And the built capital is the artifacts of civilization growth, and we refer to that as infrastructure, and it's both private and public, and it's private wealth as well as public wealth. And then, of course, natural capital. None of this would be happening if we didn't have, clean water, clean air, and all the plants that we bowed into our service over the last 10,000 years. The Doughnut Economics model is a little bit different. It kind of takes that circular model, and you can see parts of social capital in here, like gender equity, social equity, political voice. You can see the housing as built capital. You can see part of social capital is education. Part of it is your own income, peace and justice. And then the environmental forms, again, food, water, and energy up here. And so what Kate Raworth was saying is that in her book called Doughnut, with that title, Doughnut Economics, I highly recommend it, about a social foundation and then an ecological ceiling. And the shortfall of the social foundation leads to, obviously is poverty and ill health and so forth. But beyond the ecological ceiling, you have climate change, you have acid layer depletion, acidification, chemical pollution, and so forth. So the goal is to live within our means, so to speak. And you can plot this quantitatively, and this is a graph of that, beyond the boundary or not quantified, which some of these things are not that quantified in all locations, and then others that are, that are in the shortfall situation. And of course, you have to set your system boundaries. Are we talking about the population, the 200 million people in Nigeria, or the, I don't know how many people live in Del Mar, but, there's that, or even just like, if you did the same kind of graph for Fallbrook as an example. So you have to pick your geographic and or political boundaries for doing these kinds of analyses. But I just wanted to show you that that's the kind of stuff that's on my mind and what I've been thinking about a lot lately and studying. So that's pretty much it. Let's open it up for discussions, questions, and answers. I have a lot more slides down here that I could show you, like sustainable development goals and all of that stuff, but I think I've shown you pretty much what I'm engaged in.
Well, I suggest you turn off your
Want me to stop sharing?
stop sharing so that we can communicate.
Right.
Darcy had a comment. Darcy wanted you to display your contact info. Oh, yes, I told you to stop sharing.
Sure. Well, I can just put it back on that slide, I guess.
Thank you. Yes, I'm the district manager at Mission Resource Conservation District, and I heard you talk the other day at a natural carbon talk, and I would love to be in touch with you.
Oh, okay.
You did a great job. Really interesting work and great presentation. Thank you.
Oh, thank you, Darcy. Yeah, one of the things about this community work is that collaboration takes time. It means you got to talk to people and hopefully listen too. That's been my challenge. I was a teacher, so listening is key too. Actually,
Well, Dan, I don't know if this is exactly within the realm of your talk, but it does deal with infrastructure.
Yeah.
And we've heard a lot of discussion. We'll leave the political aspect of it out, but it's pretty well universally accepted that the country needs a heck of a lot of infrastructure upgrades and preferably green tied into that. I was listening to one commentator that was speaking about just the pipe issue, for example, where Biden was saying that we need to replace all the lead pipes in the country. And what the speaker was saying that, yes, we do need to do that, but they were bringing up the question, well, where does all that material come from? In other words, if you're talking about millions of miles of pipe, where does it get manufactured? Where does it come from? Where is the raw material, for doing that kind of thing? And this was just, one small sliver of the whole infrastructure question. Do you come across that issue at all? Is in this respect, the fact that by going green and doing the big projects that are needed, that we end up where we're possibly shortchanged just by virtue of raw materials and sourcing?
Well, that's a great question. You have to take, of course, each material by itself. One of Amory, some of you are probably fans of Amory Levin's, like I've been for the last 40 years. And in his book, Reinventing Fire, he and also The End of Oil, he makes the kind of quip that, we didn't end the Stone Age because we ran out of rocks, right? And we're not going to end the oil age because we're running out of fossil fuels, although we've gotten low, but we keep finding more and more in various places, even though it's harder to extract. The way is moving towards solar-based economy, obviously, and that solar-based could be PV, it can be wind, or it can be bioenergy. So it'll be all three. And in his book, Reinventing Fire, which I think I saw his presentation of it in San Diego, believe it or not, at the SG&E Learning Center there on Claremont Boulevard. We're not going to run out of metals, so that's not a problem. We're not going to run out of any of the those big macro technical nutrients. Really, the problem is what kind of pollution do we generate? And it's usually energy, like metal foundries, especially cement, by the way, because we're not going to run out of cement anytime soon. We're already starting to recycle cement and recycle road beds, as you've all seen. It's the law in California. So I'm working right now here in Sonoma County with a mining company. They're basically a rock quarry, but they also do composting. So those are essential. Rocks and plants are kind of essential to any economy. The question is can we use them regeneratively? Recycling of rocks, because they don't regrow, but we're not going to run out of rocks. But there are the precious metals, and that is an issue, especially for high tech, in our cell phones and so forth. But that means tooling the recycling, the geo-resource side of the butterfly economy. It has to be focused on design for recycling and longevity use, not designed for disposal, which is the way since World War II we've pretty much designed the economy, especially since the invention of plastics. So single-use plastics is a big problem because plastics is polluting everything. And plastics are generally made from fossil fuels. But we work with the Biodegradable Plastics Institute, BPI, because they are trying to use biodegradable plastics. They want to use biodegradable plastics for single-use plastics, particularly for foodstuffs. And The challenge with that to the compost industry is massive. We've already had a working group for a couple of years on what we call our contamination reduction working group, because plastics is a bane to composters. And if you have non-compostable plastic along with compostable plastic, by the time that gets to the facility, you just got to take it all out as best you can without getting it into the little flecks. So I think plastics pollution is one of our biggest problems. The other problem with metals, certainly you don't want lead pipes. And what they will be replacing them, as most of you probably already know or have done in your own homes or businesses, you replace it with PVC, right? So is PVC acceptable as a long-term, reusable plastic? The plastics industry has to work in parallel with our industry, and a lot of the carbon in plastics will come from these bioresources. I put that little section in there on chemicals. But all of our plastics industry constitutes in mass about 3% of the whole oil industry. In other words, we burn most of that carbon. So we can easily feed the carbon in plastics from bioresources. Basically we're growing polymers, to feed that industry. But plastics are made from syngas, straight out of basically just carbon and nitrogen and not much oxygen. So, but you have to look at each case individually. So I don't think there's going to be any problem on a resource base. The problem is the quality of the energy and the efficiency of the materials and the longevity of the materials, as I see it. I hope I answered your question.
Yes. When you speak of single-use plastics, the store that I shop at, Jimbo's, has those little small bags that you can put, vegetables in and carry them out, which, drives me nuts when I go into a conventional store and I see somebody putting bananas into a plastic bag to then put into a shopping bag. That drives me nuts. But at any rate, with Jimbo's, they have what they call compostable, what you might say are single-use, tear-off bags for putting, small groups of vegetables in.
Right.
So my question is, when they say compostable, does that mean it's biodegradable? In other words, is that something that has to go into composting, or if it ends up in a landfill, will it eventually decompose?
Oh, absolutely, it'll decompose much faster than the other plastics, even though the plastics will themselves decompose eventually too, thanks to the microbes. They go faster with UV and whether they're UV sensitive or not. So chemical and biological degradation happens. I mean, that's the way our biosphere is built. So, but we do not like compostable plastics only if it can be pure from non-compostable, because there's no way to separate it once they get commingled efficiently yet. We might have some sort of machines. In fact, we do use a lot of machines at compost facilities to do that. One of the ways, and I know Mary Matava at AgriService in Oceanside has done some some trial runs with institutions that use only compostable plastic, and then they put that they deposit that at her facility. So that's what the biodegradable plastics folks are using. But there's a difference between biodegradable, if it gets out into the environment or the landfill, versus compostable. So we've developed our own compostable regulation, and there's actually a whole association that's now nationwide called the Compost Manufacturers Alliance, which allows composters to determine which compostable plastics they can take. So we still have a long way to go with the plastics industry, but I think the plastics industry is begrudgingly saying, well, we just can't keep pumping out more plastic. But that's a process where we have to work with the plastics packaging producers, and we do. Yes, I'm sorry.
I'd like to hear your thinking on one of our real world problems here in California, where our government is trying to step back to virtually kill rooftop solar with a law, AB 1139, which would tax solar users $50 to $60 a month, because they say that we're being subsidized by lower income ratepayers. So they're trying to pit us against each other, pit ratepayers against each other. You know, so what's going to be harmed? The utilities will be satisfied, because they will continue to be able to pay their shareholders, but the environment's going to lose out because our solar industry is going to be hurt. To my way of thinking, the solution is not to start charging solar customers $50 to $60 a month extra, but to make solar energy available to everybody, including renters. And so the government needs to be more proactive, to equalize the, and I think what we need is community choice energy as the policeman, the regulator, to sit in the place of the utilities. What are your thoughts on that? Are you
Well, I actually agree
familiar
with you.
with this issue?
Oh, yeah, I'm very familiar with it. I'm involved right now in a business plan challenge competition here in Sonoma County, because our county is divided into two air districts. We have NOSORCO and we have BACMED, or Bay Area Air Quality Management District, and that controls a lot of what kind of bioenergy you can produce. But they formed a biomass.biz. And the reason the energy is important is because we're looking to use biomass energy to support the microgrids. And one of the partners in that is our local community choice power group here called Renewable. No, it's called Sonoma Clean Power. So there is a standoff right now, and we see it politically globally between the mega owners of and the shareholders of these utilities. When our house burned down, we submitted a claim, an insurance claim, because we lost more than what our insurance covered, and that claim went into the PG&E mass tort claim, and PG&E had to go. Not PG&E. Yeah, it was PG&E, not Sempra or Power. I mean, our state is run really by three monopolies, three utilities that are gigantic, and of course they're controlled, with big air quotes, by the PUC. And so there is not local control. But one of the ways to get local control is what you just already said: community choice power, and that again is at community scale. But you still need to. I think we don't want to do away with the grid because we're trading power all the time, but I think the grid management can't be borne on the backs of solar, and that's where the government has to step in to equalize that. And so I agree with you, and that's a political struggle because of the size of power versus the community, because from the size of the power in your own home. I mean, we got 3 million people in San Diego County alone that's under one utility, and you can get off.
So specifically, how can we convince Lorena Gonzalez that she's wrong? and that she needs to help us get community choice energy around the state for everybody and stop. I mean, is she just getting money from the utilities? Is that what this is all about?
I don't know what her source of money is, so I wouldn't wager to speculate. Because there's people that believe in the old economy too, and because that's where all the assets are. And so I'm tuning into, and in fact, part of another actually it's a San Diego County-based company called Entrust, which we're coming out with a new product called EcoBonds. It won't be out for another couple of years, but there's also a big divest invest movement where people are divesting their holdings in utilities and then putting them into community choice agriculture. But that means it's also a change not only of our investment system, but of our banking system. So you got to kind of be thinking and working on all fronts. And the politicians are all back and all across that spectrum. So who you support versus who the large forces support. Eventually the large investors can't, I mean, it's my intention and hope that they do come around, but the story's not told completely yet.
Cynthia has a question.
I guess I'll just read it out loud. I'm going back to Bill's questions about the compostable plastic bags.
Yeah.
Where do they go? Can we compost them at home, or do they provide petrochemical pollution to our compost, or do they go in the green?
No, the compostable are not petrochemical. They're bio-based for the most part.
So we
and
can't
they do
compost them at home.
Not necessarily, because the polymers are so robust so that they don't dissolve right when you put the food in them, that they when you add water to like cellulose bags, obviously those degrade pretty quickly, and you can compost your paper bags. It requires actually a little more heat, and thermophilic composting, which only happens in big compost piles. It doesn't happen typically on home composting. But I've seen it degrade in home composters. That's why you have to test it.
So maybe it's better perhaps put them in their green bin so they can be professionally composted.
Correct. Yeah. They would go to a thermophilic compost facility where you have to go to time and temperature in order to kill all the weed seeds and the pathogens and degrade the compostable plastics. Yes.
Thank you.
Oh, any more questions someone would like to add in the chat room or raise their hand?
Dale, can you unmute yourself? Have you allowed people to do that?
If they raise their hand, we can. Oh, no,
Unmute
they
them.
can unmute. They can unmute.
Dale, if you scroll down to the bottom left, you'll see the mute
There,
button.
he's unmuted now. He's unmuted. Oh, now he's muted.
Okay, am I
There,
good?
there you are. You're good.
Okay. All right. I'm asking these questions in a rational fashion, but I've been in and around agriculture for my whole career, and
Yeah.
and I know that the production and distribution of compost materials does consume quite a bit of energy, at least from an agricultural standpoint. Are you generating, what is the net use of materials? Are we generating fewer carbon emissions than we're sequestering in composting, or not?
Yeah, no. Well, most of the mass in a compost pile, half of it is lost to the atmosphere. So
Okay.
that carbon, it goes back in the atmosphere. But that doesn't count, even though it is a greenhouse gas, it doesn't count as one because the source was not in the lithosphere. The source was in the biosphere. So that's why it's referred to as renewable carbon. But you have to determine whether you're producing more carbon from the biosphere than you're taking back into the biosphere.
Okay.
And so, well, the energy, you can actually greatly reduce the energy used in composting. And in fact, we're doing that now. Not on all compost facilities. I guess you could say we're starting to do that. And throughout California, whenever you're either rebuilding or building a new compost facility, they're not using turned windrows. Because we did a project through my association back in 2012 where we were testing, we were comparing aerated static piles where you blow in the air and then you put on a compost cap on top rather than the turned windrows. The turned windrows, if you make 5 passes down the windrows with a 450 horsepower diesel-powered, Scarab or windrow turner, you're consuming a lot of energy there. And then every time you turn the pile, you're releasing a lot of volatile organic carbons. And so in the piles that we made, which were 35 feet by 90 feet with 3 tubes going down there, I could show you pictures, but I just imagine it. And we powered a 1.5 horsepower air motor with solar powered. And we bought a battery stack that could just retain the power and cause aeration 24/7, just based on the sun. And this was in Tulare County, nearby
Okay.
Celia.
Okay.
So, and then we reduced the volatile organic carbons, which are not greenhouse gases, but they are ozone forming gases, and that's what the air districts really care about.
Yes.
We reduced them 98%
Wow.
in that technology. So all the air districts are just adopting it. They were going to go into doing more up here in the Bay Area Air District, and they decided they didn't need to because the industry was already switching. So they just said, these are best management practices. If you're going to redesign and rebuild your facility, use these, not the others. And that's all the facilities that are going in now are aerated. In addition, the technology that I'm using from, I'm trying to get to California, trying to get our first site, their containers, shipping containers that have been refitted for composting, and then they have aerated floors, and then you hook them all together and run them through a biofilter, and you can capture especially the good off gases, but you can treat all of the volatile organics, and meanwhile it's in a container, so the water isn't flowing through the pile, because that's the other big deal in compost, is that you have too much rainwater going through the piles, which then gives you, high BOD water that could go out into the local surrounding water bodies. So they make everybody, all the composters build these ginormous ponds to collect the water, in the event of a 100-year, or it goes depending on which water region you're in. It's either a 25-year or a 100-year flood, and with the containerized compost units, there's exempt from the water boards. So we can sidestep the regulations and improve the environment and actually be more efficient, create a better product by using just the technology that we have available. You just got to use it.
I see. One last question is that are you working in biofuels that can be used for powering automobiles and also as jet fuel?
Yes, and we're still in the early days of that. You guys down near you, it's actually not that far, in San Jacinto, the first dairy manure gasification and Fischer-Tropsch facility was put in and permitted under South Coast's strictest air rules in the world. Practically, it was permitted, and we're trying to commercialize that, but there's a real problem with commercializing small refineries in small amounts, and you can use them on your farms. You have another one in Riverside that is using anaerobic digestion to power the trash fleets. So renewable natural gas, the guys who were doing the gasification were producing biochar and syngas, which then if you run through a Fischer-Tropsch, you can produce any chemical you want. And they were finding that refinery wax, which is paraffin wax in various forms, is really a good fuel because that can be turned in and manufactured into any fuels, and it can be shipped cheaply. So we're still trying to find out what are the markets in this distributed bioprocessing economy that's different from the old or the former, the one that we're still living with predominantly, fossil fuel refinery economy. Yeah. That's gonna be beyond my lifetime anyway, but I'm hoping it's within my son's lifetime.
I hope you have a long life. Let me get
Yeah.
that way.
Yeah.
Just a quick clarification. You referred to high BOD water runoff
Yeah.
from compost. What does BOD stand for?
It's biological oxygen demand. It's like when you have a lot of nutrients in the water, it's what creates the algae blooms in the lakes. It takes a lot of oxygen to metabolize all of those nutrients. So you don't want the nutrients in your surface water bodies. You don't want them in your groundwater either. You want to take care of the nutrients before it gets in the water. Of course, we've created a whole wastewater system where we actually literally consciously pollute our water. We take drinking water and then we poop and pee in it. And so now we got to take that out, and that's what the wastewater facilities do, of course. And then those nutrients are grabbed, through various stages of treatment. That's how biosolids are made. And then those biosolids then can go back out onto the farms, but it takes a special farmer to do that, number one, because there's a lot of regulations surrounding that. Most of the biosolids, I think from your wastewater treatment, probably most of you have septic tanks, right? Or are you on sewage connection?
Sewage.
Yeah. So the Fallbrook wastewater facility, can't remember where they take their biosolids. I think they go out, they're land applied in various, what I refer to them as biosolids farmers. They learned how to use biosolids appropriately, and that typically not on food crops, but they are on feed crops. Like the city of LA and LA County Sanitation Districts have become farmers. They basically bought the land, and then they have farmers create feed out of that. So that's how that loop gets closed. And in Washington State, they've even tried to brand it, and they branded it under a URL. You can look it up. It's called Loop for Your Soil. And so they just, with kids and with grown-ups and everybody, they just call it the poop loop. So, it's important because the nitrogen can get captured too. Unfortunately, we lose a lot of nitrogen in that process. So we're looking at how can we make that more efficient to capture that nitrogen and use it for fertilizer. So anyway, yeah.
I want to go ahead and jump in here just to do a time check. It's 7:40. We're already 10 minutes past the bottom of the hour, I guess I should say, but which is fine because we've had some good questions here.
Yeah.
Any final last burning ones before we let Dan go?
Deanna Parks had one. She was asking about compostable doggy poop bags.
Yeah. Those can be composted very effectively in a permitted thermophilic
It's
compost
unmuted.
facility. What's that? Was somebody trying to say something? Sorry. Okay. Yeah. So they can be composted, but different composters do or don't take them, and a lot of people, and it has to do with the concern about how they get into the green bin. I think we all have a lot to learn about that, but many municipalities don't take, and that's what makes recycling, even in the green bin, so complex, confusing to the average homeowner. The blue bin is even pretty bad too, because there's a lot of people do what we what we refer to in the industry as wish cycling. You put it in the blue bin and you just hope, you wish it'll get recycled somewhere by somebody else. We've got a lot more to do on that because we've sent a lot to China and that's stopped. Now we've got to build infrastructure. So that's part of the infrastructure we got to build.
Actually, that's a really great reminder. That is our speaker for next month.
Cool.
I mentioned at the top of the discussion that
Right.
we're going to be talking about recycling and what to put in the bin, what to not to put in the bin, and then what happens when it leaves our doorstep.
Exactly. Cool.
All right. Well, very good, Dan.
Well, thank you for the
Thank you so
invite.
much.
I hope it was useful on some level.
Very, very educational.
Yeah, very good.
Thank you. Thank you.
All right,
All
everyone.
right,
We'll
well-
see you next month.
Hey, good night.
Thanks. Bye.